Yes, good morning, my dear good evening, my dear students. Good evening, all of you. Today we are going to discuss Polymers chapter. Come to the live session, all of you. Come to live. Come to the live session, my dear students. Good evening, all of you. Today we are going to discuss Polymers chapter. Come to live. Come to the live session, my dear students. Good evening, all of you. Today we are going to discuss polymers. Yes. So today we are going to discuss about the polymers. Good evening, all of you, my dear students. My name is Lakshmanarayana. This is Ellen Brand of Chemistry. Today we are going to discuss about polymers. First of all, what are the polymers? Then what is the classification of polymers? Then after we have to discuss each and every polymer, how it is formed, then what are the monomers of that. So based on these topics, what are the previous year questions are there that we'll discuss today. So polymers, nothing but first of all, poly, nothing but many. So many, mers, nothing but molecules. So once many of the molecules are together, then polymer will be formed. So this is the actual, what is a polymer? So actually polymers classification, if you see, the classification of polymers first, if you see, classification. The classification, actually four types of classifications are there. So first classification based on the structure. So classification based on structure. So based on the structure, these are classified into three types. So what are those? So number one, linear polymers. Linear polymers. So the linear polymers such as so polythene, linear polymers such as polythene, that is high density polythene. That is high density polythene. Then one more, polyvinyl chloride. Polyvinyl chloride. Polyvinyl chloride. We call it as a PVC, polyvinyl chloride. High density polythene, polyvinyl chloride, both are example for the linear polymers. Actual structure of this is, it will be present in the linear, so there is no branches in it. So all molecules are held together, each and every one, then it will be form a linear. The next one, second one in that is branched polymers. So branched polymers or branched chain polymers we call branched polymers. So what are the branched polymers? So branched polymers nothing but, so look at the structure. In case if it will be present like this, if it will be present, then some of the branches will be formed. Some of the branches will be formed. So these we call branched polymers. So what are the example for the branched polymers? Low density polythene is branched polymer. Low density polythene. Low density polythene is branched polymer. Then next one, cross-linked polymers. That is C, cross-linked polymers. Cross-linked polymers. So what are the cross-linked polymers that we have to discuss? So cross-linked polymers nothing but, so linear polymers are held together with a cross links. With a cross links, either hydrogen bonding or sulfur bonding or disulfide bonds. So when it is present like this, then we call cross-linked polymers. Cross-linked polymers. Cross-linked polymers. Example for the cross-linked polymers are bakelite. Bakelite. Then one more, melanin formaldehyde resin. Melanin formaldehyde resin. These are the examples. So remember, linear polymers nothing but only in the linear shape it will be present. So example for the linear polymers are high density polythene, then polyvinyl chloride, then one more, so branched chain polymers. So with the linear, some of the branches are attached to that. So that we call branched chain polymers. Low density polythene is a branched chain polymer. Then next, if you take cross-linked polymers, in between the linear chains, then either CH2 units, the cross links with the CH2 units, or otherwise disulfide bonds, then otherwise hydrogen bondings. So in between them, these are the bonds will be formed that we call cross-linked polymers. Example for the cross-linked polymers are then bakelite, then melanin formaldehyde resin. So this is one of the classification. The classification is based on linear branched cross-linked polymers. Yes. So now down this, then we'll discuss one more. Yeah. Next classification how to discuss. So now second classification based on the source. The classification first one based on the structure I told. Then second classification that is based on the source. See what are those based on the source? Classification based on source. Classification based on సోర్స్. సో ఇందులో 3 ఉంటాయి. సో వాట్ ఆర్ దోస్? నెంబర్ 1, న్యాచురల్ పాలిమర్స్. న్యాచురల్ పాలిమర్స్. ఈ న్యాచురల్ పాలిమర్స్ మళ్ళీ 2 టైప్స్గా ఉంటాయి. బయోడిగ్రేడబుల్ పాలిమర్స్, నాన్ బయోడిగ్రేడబుల్ పాలిమర్స్. సో వాట్ ఆర్ ద బయోడిగ్రేడబుల్ పాలిమర్స్? Biodegradable polymers. Then one more, non-biodegradable polymers. Non-biodegradable polymers. Right? So biodegradable polymers, in case if you see, such as examples for this, starch, cellulose, starch, cellulose, protein, all these are biodegradable polymers. Then non-biodegradable polymers, in case if we take, so non-biodegradable polymers nothing but it won't decomposes by environment. Biodegradable polymers nothing but it can be decomposed by the environment. So these natural polymers generally it will come from the plants, from plants or animals. Plants నుంచి కానీ లేదా animals నుంచి కానీ ప్రొడ్యూస్ అవుతాయి ఇవి. సో అందుకే వీటిని న్యాచురల్ పాలిమర్స్ అంటాం. న్యాచురల్ పాలిమర్స్కి ఎగ్జాంపుల్ బయోడిగ్రేడబుల్ పాలిమర్స్ ఉన్నాయి, నాన్ బయోడిగ్రేడబుల్ పాలిమర్స్ ఉన్నాయి. బయోడిగ్రేడబుల్ పాలిమర్స్ ఎగ్జాంపుల్ స్టార్చ్, సెల్యులోజ్, ప్రోటీన్, దెన్ glycine, then glucagon, some other polymers also is there. Then non-biodegradable polymers example for this which are present from the plants. So that is from rubber, natural rubber we call. Natural rubber. So natural rubber అనేది non-biodegradable polymer. సో non-biodegradable polymer అంటే ఒకసారి మనం ప్లాంట్స్ నుంచి మనం తీసుకున్న తర్వాత so it won't degrade by atmosphere. So that we call it as a non-biodegradable polymers. Then second one, semi-synthetic polymers. Semi-synthetic polymers. So semi-synthetic polymers అంటే natural polymers నుంచి derivatives ని ప్రిపేర్ చేస్తాయి. So these are came from natural polymers. Natural polymers నుంచి మనం డెరివేటివ్స్ ప్రిపేర్ చేస్తాం. ఫర్ ఎగ్జాంపుల్ cellulose acetate. Then second one, cellulose nitrate. These are semi-synthetic polymers we call. ఏమంటాం వాటిని? Semi-synthetic polymers. Then third one is there. Third one, that is synthetic polymers. So synthetic polymers అనగానే మనకి these are the man-made polymers. So these are synthesis in the of industries. So that we call polymer industries. That we call man-made polymers. So ఈ man-made polymers ఏమేమి వస్తాయి ఎగ్జాంపుల్స్ అంటే, సో ఎగ్జాంపుల్ ఫర్ ద man-made polymers are all the polymers such as polythene, polyvinyl chloride, then Teflon, nylon, all these polymers are synthetic polymers. So synthetic polymers, semi-synthetic polymers, natural polymers. So this is the second classification. Then one more classification is there. So based on the intermolecular forces, one more classification is there. Better to note the examples, all of you, please. Better to note the examples. Hi, good evening, good evening. Good evening, all of you. Yes, classification based on the sources. So classification based on the sources, we are seeing classification based on the intermolecular forces. Classification based on the intermolecular forces. So what are those? These are the very important. So based on intermolecular forces. Intermolecular forces. Classification based on the intermolecular forces. So first one we are taking in this, that we call elastomers. What we call? Elastomers. So elastomers లో ఏముంటుంది అంటే వీక్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఉంటాయి. వీక్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఉంటే, ఈ వీక్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఉంటే వాటిని మనం ఎలాస్టోమర్స్ అంటాం. వీక్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఆర్ ప్రెసెంట్. వీక్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఉంటే దెన్ మనం ఏమంటాం? సో ఎలాస్టోమర్స్ అంటాం. సో ఎలాస్టోమర్స్ కి ఎగ్జాంపుల్ ఏంటి? వాట్ ఆర్ ద ఎగ్జాంపుల్స్ ఫర్ ద ఎలాస్టోమర్స్? సో సచ్ యాజ్ natural rubber, then vulcanization of rubber, so vulcanization rubber, Buna S, Buna N, so Buna S, then Buna N, so ఇవన్నీ కూడా రబ్బర్సే. దెన్ నియోప్రీన్, సింథటిక్ రబ్బర్ అంటాం దీన్ని. నియోప్రీన్ సింథటిక్ రబ్బర్, ఇవన్నీ కూడా రబ్బర్స్ మా, సింథటిక్ రబ్బర్. సో ఎలాస్టోమర్స్ అనగానే మనం చెప్పాల్సింది, ఎలాస్టోమర్స్ అన్నీ కూడా రబ్బర్సే. సో వీటిల్లో వీక్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఉంటాయి. సో రబ్బర్స్ ఏమేమి? న్యాచురల్ రబ్బరు, వల్కనైజేషన్ రబ్బరు, బ్యూనా ఎస్ ఆల్సో రబ్బర్, బ్యూనా ఎన్ ఆల్సో రబ్బర్, నియోప్రీన్ ఇట్ ఇస్ ఎ సింథటిక్ రబ్బర్. Natural rubber, vulcanization of rubber, it is taken from the trees. Then Buna S, Buna N, it is man-made polymers. Then neoprene also man-made, it is a synthetic polymer, synthetic rubber we call. Then second one fibers. So fibers lo strong intermolecular forces ఉంటాయి. So strong intermolecular forces. Intermolecular forces. So what are the example for the fibers are, so fibers, polyamides, nothing but nylons. Polyamides antam. Polyamides, nylons are the examples. Polyesters, polyester antam chusara, polyester, so that is example terylene or dacron అని కూడా వచ్చుదాన్ని. Dacron, terylene or dacron. Then some other fibers, wool, silk, cotton, then nylon, then rayon. So all these are fibers. సో ఎలాస్టోమర్స్ అంటే వీక్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఉంటాయి, ఫైబర్స్ అంటే స్ట్రాంగ్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఉంటాయి. సార్ ఇవి థ్రెడ్ని ఫామ్ చేస్తాయి, థ్రెడ్ని ఫామ్ చేస్తాయి. సో వీటిని ఫైబర్స్ అంటాం. సో వీటన్నిటికీ ఎగ్జాంపుల్స్ నోట్ చేయండి. ఎగ్జాంపుల్స్ నోట్ చేశారా? సో నెక్స్ట్ we have to discuss, that is, so remember one more important point in the fibers. Strong intermolecular forces, nothing but strong hydrogen bonding is present. So strong hydrogen bonding, remember, strong hydrogen bonding is present in it. Then next one, thermoplastics. Thermoplastic polymers. Thermoplastic polymers. Third one indulo thermoplastic polymers. Thermoplastic polymers. సో ఏంటివి సార్ థర్మోప్లాస్టిక్ పాలిమర్స్? ఇందులో ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఎలా ఉంటాయంటే సార్, ఇంటర్మాలిక్యులర్ ఫోర్సెస్ ఆర్ ఇంటర్మీడియట్ బిట్వీన్ ద ఫైబర్స్ అండ్ ఎలాస్టోమర్స్. ఎలాస్టోమర్స్ కి ఫైబర్స్ కి యాక్చువల్గా ఎలాస్టోమర్స్ చూసాం ద వీక్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్, ఫైబర్స్ చూసాం స్ట్రాంగ్ ఇంటర్మాలిక్యులర్ ఫోర్సెస్. ఇన్ కేస్ ఇఫ్ యూ టేక్ థర్మోప్లాస్టిక్ పాలిమర్స్, intermolecular forces are intermediate between the elastomers and fibers. So in these polymers, intermolecular forces are intermediate between fibers and elastomers. Sir, here one of the important qualities there for the thermoplastic polymers. So enta important quality ante, so these are the linear and slightly branched. One is these are linear and slightly branched. That is one. Then one more. So softening on heating, hardening on cooling. So heat cheste soft అయిపోతాయి. Softening on heating and hardening on cooling. So remember, so this is one of the important quality for the thermoplastic polymers. అందుకే thermoplastic polymers ని మళ్ళీ మనం రీయూజ్ చేయొచ్చు. These polymers we can reuse again. Which are thermoplastic polymers. Thermoplastic polymers softening on heating, heat చేస్తే సాఫ్ట్ అయిపోతాయి. హార్డెనింగ్ ఆన్ కూలింగ్, సో కూల్ చేస్తే మళ్ళీ హార్డ్ అయిపోతాయి. సో వాట్ ఆర్ ద ఎగ్జాంపుల్ ఫర్ ద థర్మోప్లాస్టిక్? సార్ పాలిథీన్ అండ్ పీవీసీ, polyvinyl chloride. So one more, thermosetting polymers, fourth one, thermosetting polymers. So these cannot be reused again. సో వీటిని మళ్ళీ రీయూజ్ చేయలేము. అదే థర్మోప్లాస్టిక్ పాలిమర్స్ అయితే we can reuse again. So examples for this, bakelite and urea formaldehyde resin. Examples for this, bakelite and urea formaldehyde resin. Say bakelite anedi, say it like a film. In case if you see any scanning like MRI, then CT scans, one of the film they will give, so that film, it is made up of bakelite. Okay, so in the photo films, previous photo films, they will give for the black and white photos, right? So that is also, it is made up of bakelite. So it is one of the old polymer. So thermosetting polymers cannot reuse again. So thermoplastic polymers we can reuse again. What are those? Polythene and then polyvinyl chloride we can reuse again. So these are the classifications. Then some other classifications are there. That is mode of polymerization. Classification based on the mode of polymerization. Classification based on mode of polymerization. So listen, my dear students, if you listen carefully, if you note carefully what I am writing the examples. So all the examples are collected from the textbook, either NCERT textbook or state syllabus textbook. These all examples are very useful for when we are doing the previous year questions or for the next examination questions. So next, classification based on mode of polymerization. Mode of polymerization. Mode of polymerization. Classification based on mode of polymerization. Indulo, so number one, addition polymers. Addition polymers. Sir, addition polymers ela form avutayi ante, so by using free radical mechanism. Free radical mechanism dwara ఇది ఫామ్ అవుతుంది. సో వీటిని చైన్ గ్రోత్ పాలిమర్స్ అని కూడా అంటాం. సో దీస్ పాలిమర్స్ ఆల్సో కాల్డ్ యాజ్ chain growth polymers. సో చైన్ గ్రోత్ పాలిమర్స్ ఫామ్ అవుతాయి. సో అడిషన్ పాలిమర్స్ అన్ని కూడా చైన్ గ్రోత్. See, addition polymers, same kind of polymers kani, same kind of monomers kani, different kind of monomers kani, so linked with one another, that we call, sir, addition polymers. Enti? Same kind of monomers are different monomers linked together. వీటిని ఏమంటున్నాం? అడిషన్ పాలిమర్స్ అంటున్నాం. It is also called as chain growth polymers. So chain will be increased for this. Sir, what are the examples for the addition polymers? Sir, ఇందులో I told that same kind of monomers and different kind of monomers. Two examples చెప్పాను. సో సేమ్ కైండ్ ఆఫ్ మోనోమర్స్ ఉంటే వాటిని హోమోపాలిమర్స్ అంటాం. హోమోపాలిమర్స్. సేమ్ కైండ్ ఆఫ్ మోనోమర్స్ ఉంటే homopolymers అంటాం. They will ask a question, sir, which of the following is homopolymer or which of the following is copolymer? Sir, look at homopolymer, nothing but it is, so only one kind of or same kind of monomers is involved in it. In this different kind of, that we call copolymer. So in case two molecules are linked together with one another, then we call copolymer. So that two molecules are different monomers. Clear? So what are the homopolymers? That I will give examples to you. So one is polythene. So number one, polypropene. Number three, polyvinyl chloride. Number four, polyacrylonitrile. Then so one more name there, orlon. So polyacrylonitrile. Simply we call it the PAN. PAN. Polyacrylonitrile. Then one more, Teflon. Sir, homopolymers. Ivanni kuda homopolymers. So note all the examples are very important to you. Then even synthetic polymer and a natural, synthetic rubber and natural rubber also. Number one, synthetic rubber. And number two, natural natural rubber. Remember, synthetic rubber, natural rubber. So these two rubbers also homopolymers. Then next to polythene, polypropene, polyvinyl chloride, polyacrylonitrile, then Teflon. All these are homopolymers. ఇవన్నీ కూడా homopolymers. Then next one copolymers. So copolymers only two ఉన్నాయి. అది addition polymers లో two నే ఉన్నాయి. So what are those అంటే buna N, then buna S. Buna N, buna S. These two are copolymers. Sir, all these polymers one by one I will discuss. One by one I will discuss. So what are the addition polymers are there? So first, what are the monomers for the addition polymers? What are the monomers for homopolymers that we have to discuss? So look at first what will be there, man. So polythene is there. So number one, what is there? Polythene. Polythene. So polythene, it is one of the polymer. So monomer for the polythene is ethene. Monomer is ethene. So structure of ethene is CH2 double bond CH2. CH2 double bond CH2. Then this monomer, in case whatever the monomer are there. Sir, what is that? CH2 double bond CH2. ఏమంటున్నాం దీన్ని? ethene అంటున్నాం. Sir, how many molecules are there? N number of molecules are there. When polymerization takes place, then what will be formed? Bond CH2, bond CH2, bond N. So these molecules, observe carefully, ఏం ఫామ్ అవుతా ఉంది. సో నేను ఇందాకే చెప్పాను, this is free radical mechanism takes place, I told. Sir, for example, in case CH2 double bond CH2 is there. Once free radical mechanism takes place, sir, one of the bond will be homolytic cleavage like this. Homolytic cleavage జరిగితే ఏం జరుగుతా ఉంది? సో ఇక్కడ ఒక రాడికల్, ఇక్కడ ఒక రాడికల్ వస్తుంది. So these are how many? N number of ethene molecules. Sir, one more ethene molecule also it will be formed. CH2 bond CH2. ikkada free radical, ikkada free radical. Then malli, sir, CH2 bond CH2. ikkada free radical, malli ikkada free radical. Sir, ఇవన్నీ ఏమవుతున్నాయి? ఒకదానికొకటి కనెక్ట్ అవుతా ఉన్నాయి. సో ఒకదానికొకటి కనెక్ట్ అవుతా ఉన్నాయి. సో ఇలా కనెక్ట్ అవుతున్నప్పుడు ఏం ఫామ్ అవుతుందని చెప్పండి. Then bond CH2, 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 like this will be there. Observe that CH2 bond CH2 is repeatedly formed in the polymer. So that is what we are taking. CH2 bond CH2 taken n times it will be formed. So that is we call polythene. ఇందులో ఈథీన్ నెంబర్ ఆఫ్ టైమ్స్ ఫామ్ అయింది కాబట్టి దాన్ని మనం పాలీథీన్. సో ఈథీన్ పాలీథీన్ గా కన్వర్ట్ అయింది. సో నెక్స్ట్ వన్ పాలీప్రొపీన్, రైట్. సో పాలీప్రొపీన్ మోనోమర్, we can say simply monomer. ఏంటి సార్ మోనోమర్? ప్రొపీన్ ఇస్ అ మోనోమర్. ఏంటి మోనోమర్? ప్రొపీన్ ఇస్ ద మోనోమర్. సో ఎలా ఉంటుంది ప్రొపీన్? సో సేమ్ స్ట్రక్చర్, దాని డెరివేటివ్ ఉంటుంది. లుక్ ఎట్ all of you. CH2 double bond CH, then CH, one of the hydrogen place it will be formed CH3. Then we call propene. So 1 2 3, so 3 carbons are there in the chain, prop, then double bond is there, we call it as propene, right? Yes. So now in case the same compound, n number of compounds if we take CH3, then double bond of CH2. Yes, look at, then n number polymerization it happens. Then what form? So bond, then CH, bond CH2, bond N, then here CH3. So this is called polypropene. దీన్ని మనం polypropene అంటున్నాం. polypropene. So polythene, polypropene. Next polyvinyl chloride. Polyvinyl chloride. Next one is what? Polyvinyl chloride. This is polypropene. Polypropene. So look at my dear students, all these examples are very important when we're doing questions. So polyvinyl chloride. Vinyl chloride. So monomer is vinyl chloride. How it will be vinyl chloride, man? CH double bond CH2 then Cl. This is vinyl chloride. What we call it is vinyl chloride. ఏమంటాం దీన్ని? Vinyl chloride. So vinyl chloride, number of times it will be repeat. See, look at CH bond Cl double bond CH2. ఇవన్నీ కూడా ఈథీన్ డెరివేటివ్స్ ఏమా? ఒక CH2 డబుల్ బాండ్ CH2 లో ఒక హైడ్రోజన్ ప్లేస్ లో CH3 అటాచ్ అవుతే ప్రోపీన్ అన్నాం. సో క్లోరిన్ అటాచ్ అయి ఉంటే వినైల్ క్లోరైడ్ అన్నాం. సో వినైల్ క్లోరైడ్ n టైమ్స్ పాలిమరైజేషన్ జరిగితే దెన్ ఏం ఫామ్ అవుతుంది చెప్పండి? బాండ్ CH Cl bond then CH2 bond n times, that we call polyvinyl chloride. Polyvinyl chloride. Next, yes, note down all these monomers and as well as structures. Monomers as well as structures. This class is for EAPCET examination, man. EAPCET examination. Yes, note down this. Yes. Next, polyacrylonitrile. Polyacrylonitrile. This is fourth one. Polyacrylonitrile. Sir, PAN we call PAN. Then R, one more name is there for this. Orlon. Pon or Orlon. So monomer for polyacrylonitrile. They will ask a question, what is the monomer? Monomer enti. Acrylonitrile. Even it is also ethene derivative only. Sir, one of the hydrogen place it will be attached Cn. This is we call acrylonitrile. This is acrylonitrile. So number of monomers when it is attached with one another. For example, look at say n number of monomers. CH, CH double bond, CH2 bond, CN, right? Then polymerization takes place. Polymerization takes place. Then bond CHCN, bond of CH2. So like this will be formed. So this is what? Polyacrylonitrile. Polyacrylonitrile. Then one more example, sir. One more example for the homopolymer. Addition polymers lo homopolymer. Addition polymers lo homopolymer. One more example. That is fifth one, Teflon. 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 Teflon monomer. Monomer enti? Teflon monomer enti ante? So that is tetrafluoroethene. 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 Teflon. Tetrafluoroethene. Teflon. See, look at my dear students, Teflon, how it will be present. Then tetrafluoroethene, how it will be present? That CF2 double bond CF2. CF2 double bond CF2. Even it is also ethene. Ethene, what we call ethene. Ethene derivative only. So this is tetrafluoroethene. So tetrafluoroethene, polymerization takes place. Polymerization takes place. Then what will be formed? Bond CF2, bond CF2. Then close that. Then N will be there. This we call Teflon. 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 Okay. So remember, my dear students, the homomers are in the addition polymers. Addition polymers lo homomers. Homopolymers. So homopolymers ennu unnai ante, sir, these are 5. So what are those? So polythene, polyvinyl chloride, polypropene, polyacrylonitrile, then Teflon. Then some other copolymers are there. So what are the copolymers, ma'am? So copolymers, addition polymers lo copolymers. Addition polymers lo copolymers. Copolymer. Enti copolymer ante? So copolymer nothing but addition of different kind of monomers. Addition of different kind of monomers. Addition of different kind of monomers. Different kind of monomers. Examples for this: number 1, Buna S. Buna S. See, look at my dear students, Buna S lo Bu nothing but, sir, Bu nothing but 1,3 butadiene. Butadiene. So 1,3 butadiene structure ela untundi? CH2 double bond CH, bond CH, double bond CH2. This is 1,3 butadiene. So why we are calling 1,3 butadiene here? So 1, then 2, then 3, then 4. Say, look at it. First position double bond, third position double bond. That's what? 1,3. So total 4 carbons. So 4 unte buta. Diene. So 2 bonds, 2 double bonds unnai kabatti diene annam. 1,3 butadiene. Then in the law, S nothing but, second one, S nothing but styrene. Styrene. So styrene structure also, it is one of the derivative of ethene. So CH double bond CH2 is there. So here the derivation, that is we call the benzene is attached to there. Phenyl group is attached to there. This is what we call styrene. So rendu addition avute Buna S ane synthetic rubber okati form avutundi. So ela form avutundi adi. So chudandi, first N moles of 1,3 butadiene we are taking. CH2 double bond CH bond CH double bond CH2. So ఏమంటున్నాం the monomer ni 1,3 butadiene అంటున్నాం. 1,3 butadiene. Then n moles of styrene. So what is there styrene man? CH double bond CH2. Then at this position, then benzene ring will be present. That is we call styrene. Styrene. Then both will be connect with each other. With each other. Then addition polymerization takes place. See how these are connected. So wherever the double bond is there, that will become single bond. The single bond is there, that will become double bond. So how it will be formed? Look at bond CH2. Then double bond on the chote em ravale, single bond. Then CH. Then single bond on the chote em ravale, double bond CH bond CH2 bond. So ikkada variki complete అయిపోయింది. Then come to there. Then bond CH. Then bond CH2. Yes, here benzene ring will be formed. This is we call Buna S. దీన్నే మనం Buna S అంటున్నాం. Okay, understand my dear students? So Buna S is made up of 1,3 butadiene, Hi, good evening all of you. Yes, this is Buna S. Next we have to take Buna N. Buna N. Buna S, then Buna N. Then Buna N. So what is the Buna N? So again, Bu nothing but 1,3 butadiene. 1,3 butadiene. Sir, N nothing but acrylonitrile. Acrylonitrile. TRILE, nitrile. So what is the structure of nitrile, man? CH double bond CH2. Then in the place of hydrogen CN, acrylonitrile. Then 1,3 butadiene, CH2 double bond CH, bond CH double bond CH2. This is what we call 1,3 butadiene. ఈ రెండు అడిషన్ జరిగితే ఫామ్ అయ్యేదే Buna N. So how it is formed? So look at, first we have to take n moles of 1,3 butadiene CH2 double bond CH, bond CH double bond CH2, 1,3 butadiene plus n moles of acrylonitrile CHCN, then double bond CH2, acrylonitrile. When the addition of both, polymerization takes place. Then wherever the double bond is there, it becomes single bond. Single bond double bond ga convert avutundi. Then bond, then tell me CH2, then bond CH, double bond CH, then bond CH2, then bond CH, then CN, then bond CH2. Like this. This is we call Buna N. Acrylonitrile. Then 1,3 butadiene. So ఈ రెండింటిని మనం monomers అంటున్నాం. They will ask a question, what are the monomers of Sir Buna N? So Buna N monomers ఏంటి? 1,3 butadiene and acrylonitrile are Buna N monomers. What are the monomers of Buna S? 1,3 butadiene, then styrene. Styrene is a Buna S. So all these are addition polymers. So next we have to discuss about the condensation polymers. Next one we have to discuss condensation polymers. Condensation polymers. Condensation polymers. So condensation అంటే ఏంటి? So when two molecules are attaching one another, then by the elimination of ammonia molecule or by the elimination of simple molecule like H2O, then form a polymer that we call condensation polymer. So what are the condensation polymers? When two molecules, nothing but monomers held together and form a polymer by loss of simple molecules like ammonia, water, etc. సో ఇలా ఉంటే దాన్ని మనం కండెన్సేషన్ పాలిమర్స్ అంటున్నాం. వాట్ వీఆర్ కాలింగ్ కండెన్సేషన్ పాలిమర్స్. సో ఈ కండెన్సేషన్ పాలిమర్స్ ఇందులో కూడా హోమో పాలిమర్ ఉంది, దెన్ అడిషన్ దట్ ఈస్ కో పాలిమర్స్ ఆల్సో ఇస్ దేర్. కో పాలిమర్ అంటే ఇట్ ఈస్ ఫార్మ్డ్ బై two monomer units, then we call two different monomer units, then we call copolymer. So first we'll see one of the homopolymer. It is one of the best example for the condensation polymer, that is homopolymer. That is nylon 6, just nylon 6. See, nylon 6 యొక్క మోనోమర్ ఏంటి? సో నైలాన్ 6 కి ఒకే ఒక్క మాలిక్యూల్ ఉంటుంది మోనోమర్, దట్ ఈస్ caprolactam. మోనోమర్ is caprolactam. లాక్టమ్ అంటే సైక్లిక్ అమైడ్, caprolactam, caproic acid, caproic amide. Say look at C double bond O, then NH ఉంటే దాన్ని అమైడ్ అంటాం, మనకు తెలుసు. సో C double bond O NH ఉంటే then it is connected with 5 CH2 molecules, CH2, then CH2, then CH2, then CH2, then like this. So ఇలా ఉంటే 5 CH2s ఉంటే then that we call caprolactam. So caprolactam అనే molecule, so n number of caprolactams. So how it will be there? Caprolactam structure C double bond O NH, then CH2, then CH2, then CH2, then CH2, and 1 2 3 4, then final CH2 bond NH. Then it will be break here, ikkada break avutundi when polymerization is going on. Yes, what will be formed? Look at C double bond O, CH2s are 5, then NH bond, then close that. So this is we call nylon 6. Nylon 6. So nylon 6 is made up of caprolactam. ఏమంటున్నాం దీన్ని? caprolactam. Caprolactam. Clear all of you? So this is one of the condensation polymer. So next condensation polymers are copolymers. So copolymers ante two different monomers తో కనెక్ట్ అయ్యి సో పాలిమర్ ఫామ్ అవుతే దాన్ని మనం కోపాలిమర్స్ అంటాం. కండెన్సేషన్ పాలిమర్స్ లో కోపాలిమర్స్. కండెన్సేషన్ పాలిమర్స్ కి ఎగ్జాంపుల్ ఏంటి? అసలు కండెన్సేషన్ పాలిమర్స్ అంటే ఏంటి? రెండు మాలిక్యూల్స్ ఒకదానికొకటి కనెక్ట్ అయిపోయి, సో వెన్ ఇట్ ఈస్ కనెక్ట్ వన్ విత్ another, then simple molecules like H2O and NH3 will be removed from it. That we call copolymer. See, look at my dear students, the copolymer, condensation polymers. So copolymer ఏమేమి ఉన్నాయంటే number 1 nylon 6,6, nylon 6,6, then pteryline, pteryline, pteryline. దీన్నే డాక్రాన్ అని కూడా అనొచ్చు. దెన్ థర్డ్ వన్ గ్లిప్తాల్, గ్లిప్తాల్. దెన్ ఫోర్త్ వన్ గ్లిప్తాలు. దెన్ ఫోర్త్ వన్ one more bakelite, bakelite. Then fifth one melanin formaldehyde resin, melanin formaldehyde, melanin formaldehyde resin. We'll discuss all these things. So look at, my dear students, look at all the polymers, all the polymers. Look at right one by one. See, so first one, in case if you take nylon 6,6, nylon 6,6. So what are the monomers of nylon 6,6? Number one is that is hexamethylene diamine, hexamethylene diamine. So CH2, hexa nothing but CH2, CH2s are 6. So hexa nothing but 6, hexamethylene 6 CH2s, diamine NH2 bond NH2, hexamethylene diamine. Second one వచ్చేసి adipic acid, adipic acid, adipic acid లో కూడా 6 కార్బన్స్ ఉంటాయి. CH2s are 4, then COOH, then bond COOH, then adipic acid. Nylon 6,6 లో ఒకటేమో hexamethylene diamine, so one more adipic acid, hexamethylene diamine, one more adipic acid. See, look at these two when connect with each other, then H2O molecules will be lost, then form a nylon 6 polymer. How it is? So n number of hexamethylene diamine if you take, ఏమున్నది NH2 CH2 taken 6, then bond NH2 is there. When it is connected with n moles of adipic acid, adipic acid structure is what? Sir, CH2 taken 5, right? COOH, then bond CH2 taken 4, then COOH, right? When both are connected with each other, then what will be formed? See, look at when it is starts from here, sir, NH, then CH2 taken 6, then NH, then look at here, one of the OH from here, one of the H from here, by the loss of n moles of H2O molecules. Simple molecule, simple H2O molecule, simple molecules like H2O, it will be eliminate. That we call condensation polymers, I told. So H2O molecules eliminate outai. Then ఇక్కడ ఏం ఫామ్ అవుతుంది? C double bond O, then CH2 taken 4, then COO, the CO bond. So like this will be formed. This is we call nylon 6,6. దీన్నే మనం nylon 6,6 అంటాం. So next pteryline లేదా dacron, pteryline or dacron. See, look at what are the monomers of nylon 6,6 అని క్వశ్చన్ అడుగుతా ఉంటాడు. nylon 6,6 monomers ఏంటి? hexamethylene diamine, then adipic acid. Both are example for the nylon 6,6. Next ones are pteryline. Second one is what? Pteryline. దీన్నే మనం dacron అంటాం. So dacron examples or dacron monomers, one is ethylene glycol. So name I'm writing first, ethylene glycol. So what is the formula for ethylene glycol? CH2 bond OH, then bond OH. This is ethylene glycol. So next one, sir, terphthalic acid. One more example, one more monomer, terphthalic acid. Terphthalic acid ఎలా ఉంటుంది? See, look at 4th position, COOH, then bond COOH, సో 1,4 పొజిషన్లో కార్బాక్సిలిక్ యాసిడ్ డైకార్బాక్సిలిక్ యాసిడ్ ఉంటే బెంజీన్కి అటాచ్ అయ్యింటే దాన్ని మనం టెర్థాలిక్ యాసిడ్ అంటాం. టెర్థాలిక్ యాసిడ్ బెంజీన్కి 1,4 పొజిషన్లో అటాచ్ అయ్యాలి, దాన్ని మనం టెర్థాలిక్ యాసిడ్ అంటాం. సో ఇవి రెండు ఒకదానికొకటి కనెక్ట్ అయిపోతే then by the loss of H2O molecules, look at how it will be formed. Sir, first ethylene glycol, CH2 bond CH2, CH2 bond CH2, then what will be there? OH, then bond OH, then plus n moles of, this is what? Benzene structure, ma'am. Benzene, sir, COOH, then bond COOH. What I told, sir, one of the H, then one more OH, by the loss of n moles of H2O molecules. Simple molecules, it will be loss, then form bond O, then CH2 bond CH2 bond by the loss of, so look at O, C double bond O, then benzene structure, bond C double bond O, C double bond O, like this will be there. See, look at, so this is what, so C double bond OOR, that we call COOR. This is ester, the ester polyester, we call polyester. One of the example, polyester ki example enti, terylene. Terylene, it is one of the polyester, polyester we call. Yes, note all this. Next one, glyptol. Terylene is done, then glyptol. So glyptol, what are the monomers? Again, ethylene glycol and phthalic acid, not terphthalic acid. So glyptol తీసుకుంటే glyptol monomers, number 1 ethylene glycol, ethylene glycol, structure ma CH2 bond CH2, then OH, then OH. This is the structure for ethylene glycol. Then phthalic acid, second monomer, phthalic acid, P silent ikkada, phthalic acid. Phthalic acid ఎలా ఉంటుంది? Benzene attached with COOH, COOH. Adjacent position లో COOH groups ఉంటాయి, then we call it as phthalic acid. Next, then both, when it is connected with one another. So first we are taking n moles of CH2 bond OH, then bond OH, then plus n moles of COOH, then bond COOH, right? So when both are connected, n moles of, then bond O, then CH2, then CH2. See, look at here. So here H2OH will be eliminated by the loss of n moles of H2O molecules. By the loss of n moles of H2O molecules, then O bond C double bond O bond, then see, look at benzene structure as usual, then C double bond O, then like this. So n number of molecules will be formed by the loss of this. Understand, my dear students? Understand, all of you? This is also one of the ester, C double bond O, OR. So OR type of structure, and COOR type of structure is there. So that is what we call it as ester. ఇది కూడా గ్లిప్టాల్ అనేది కూడా ఒక ఎస్టరే, పాలిఎస్టర్. నెక్స్ట్ బెకలైట్ అండ్ యూరియా ఫార్మాల్డిహైడ్ రెసిన్. Bakelite and urea formaldehyde resin. So look at bakelite బెకలైట్ ఎలా ఉంటుంది? సరే యాక్చువల్గా బెకలైట్ మోనోమర్స్ వచ్చేసి monomers, very simple monomers such as phenol, then number two phenol ఒకటి, so number two monomer urea, sorry, formaldehyde. So what is the formaldehyde? HCHO, formaldehyde, urea, formaldehyde, phenol formaldehyde, not urea, phenol formaldehyde. So both when it is connected with each other, actually so first phenol is there, phenol when it is treated with HCHO, so actually HCHO ఎలా ఉంటుంది? C double bond O, H bond H. So in the presence of acid, so in between both reaction taking place, then it will be formed CH2 plus, then OH, like this will be formed. ఇలా ఫామ్ అవుతుంది. సో ఇవి రెండు కనెక్ట్ అయితే సార్ ఫార్మాల్డిహైడ్ అండ్ H plus will be connect. So why sir? So formaldehyde, what I told, C double bond O, H bond H I told, right? So here partially negative charge, here partially positive charge. One bond is shifted to there, wherever the negative charge is there, H will be attached. So by the addition of H plus, then COH will be formed, then H to H as usual, then positive charge as usual. That is what we are calling CH2 plus OH. CH2 plus OH will be formed. The CH2 plus OH, it is act as a electrophile. So phenol is electron donating group, sir, because the presence of lone pair of electrons on it. So this will be delocalization in the ring. Electrophilic substitution takes place. Where electrophilic substitution takes place? Ortho and para positions, because it is electron donating group. So CH2OH, then such type of compound, or otherwise the phenol attached, so CH2OH, then bond of CH2OH, then even the para position, the OH, then CH2OH, then CH2OH, then CH2OH, like this will be formed, right? So from these, one of the molecule, so this is the molecule, look at, so whatever the molecule we are taking, so ee molecule nunchi, so novolac ane polymer form avutundi, so ee molecule nunchi, then ee molecule nunchi bakelite ane polymer form avutundi. So two polymers form avutayi, bakelite okati, novolac okati. So ee rendu monomers nunchi novolac, bakelite ane two polymers form avutayi. So first manaku kavalsindi ikkada bakelite kabatti, so bakelite ఎలా ఫామ్ అవుతుందో చూద్దాం. Say look at whatever the monomers are there. So this, the benzene, the OH, then CH2OH, right? So this will be connected with the next one, benzene attached with OH, then CH2OH. Clear? The next, benzene attached with OH, then CH2OH. So all these are connected with one another. ఒకదానికొకటి కనెక్ట్ అవుతా వస్తాయి. సో ఎలా కనెక్ట్ అవుతాయి అంటే by loss of HO molecules. See look at. So H from here, OH from here. H from here, OH from here. So same. So entire in between them CH2 linkages will be formed. CH2 linkages will be formed. CH2 linkages will be formed. Even here also CH2 linkage. Even the same polymer, then repeat once again. Look at the linear polymer, one more. So OH, then CH2, then bond OH, then CH2. So here again formaldehyde, CH2 bond CH2, then CH2 bond CH2, then CH2, then CH2 bond CH2, then CH2, 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 like this will be formed. See, look at. So this is called Bakelite. సో ఇలా క్రాస్ లింక్స్ లీనియర్ పాలిమర్ ఫామ్ అవుతూ దాని మధ్యలో క్రాస్ లింక్స్ ఫామ్ అవుతాయి కాబట్టి దీన్ని క్రాస్ లింక్డ్ పాలిమర్ కి ఎగ్జాంపుల్ గా చెప్తాం. క్రాస్ లింక్డ్ పాలిమర్ ఎగ్జాంపుల్ దిస్ ఇస్, సో విచ్ ఇస్ Bakelite. దెన్ thermosetting polymer, not thermoplastic, thermosetting polymer it is. So these cannot reuse again, మళ్ళీ దీన్ని రీయూజ్ చేయలేము. సో దీస్ ఆర్ ద పాలిమర్స్ వాట్ we are discussed. Then last one, melanin formaldehyde is there in it. మెలనిన్ ఫార్మాల్డిహైడ్ కూడా ఉంది. వాటి మోనోమర్స్ మనం మెయిన్ గా గుర్తుపెట్టుకోవాలి. వన్ ఈజ్ మెలనిన్, వన్ మోర్ ఫార్మాల్డిహైడ్. మెలనిన్ ఫార్మాల్డిహైడ్ రెజిన్ తీసుకుంటే మెలనిన్ ఫార్మాల్డిహైడ్ resin if you take. So melanin structure, so if you see the melanin structure, one of the monomer is what? Melanin. So how it will be present, the melanin, you know? So nitrogen, then see, look at benzene type of structure it will be formed. Same like that, alternative double bonds also is present. Wherever the CH will be present, there NH2 man, NH2, then NH2. So this is we call melanin structure. So one more, formaldehyde, everyone knows formaldehyde. So HCHO, formaldehyde. So in between them, so condensation polymer will be formed. That polymer is called as melanin formaldehyde resin. So last, biodegradable polymers are there. So biodegradable polymers, nothing but the polymers which can be decomposed by the bacteria or by decomposed by the environment is called as biodegradable polymer. Biodegradable polymers